Hey guys. Alright, last video, it ran about 20 minutes and I was trying to cut it off and I hurried through there at the end. So we're going to do a quick recap. Step one was the lead term, and that gave us our end behavior. We knew that the right side relative to 0 was increasing and the left side was decreasing. Step two, we found the zeros, and that gave us our x-intercepts, which allowed us in step three to divide the x-axis into those intervals. From step one, we were able, from viewing the end behavior, we knew that it was negative and positive. So we needed to find out what the signs were in here. And that involved us going to step four and in selecting a number out of that interval and plugging it into the function and finding the value, whether it was positive or negative. So we found that the green lines indicate how the graph will go: increase, decrease, increase. Step five was the y-intercept, which ended up being one of our points from step four. Step six, we used multiplicity to verify if the values, if the graph would cross the x-axis. We saw that already. Step seven, additional points. I need to point out, I was trying to hurry and I was looking on values off of my table on the calculator, and I will show y'all that later. And I wrote down the wrong value, so I'm sorry about that. And then what we also need to do was, I didn't add that, is for our end behaviors we need at least 1 point to illustrate, and those are from the left end behavior and the right end behavior, -3 and 3, and the subsequent values. So let's actually look at it on here if we were going to graph it. You don't have to do this for your homework, but what I've done is I've taken the information like they've done in the textbook and present a graph. Whenever I work problems like that, I don't work them how I showed you or by using this. I just use a number line and I use arrows and plus or minus signs to show increase, decrease, and positive or negative, where it's located at. Down here, what I've done is I've taken the points that we've found from our work, and this is the points that we're going to plot to graph our function. So the first point, well, first off, I want to make sure you remember that y is f of x, so this is just a -3 comma -40. Also, to point out, graphing by hand is actually very difficult due to how quickly a graph can grow. We'll say it that way. For instance, I'm at a -3, and here is a -3. But I'm all the way down at a -40. I would have to put 2 or 3 of these pieces of paper together in order to graph this out. So somewhere down here I will have a point. Okay, and again, this is broken down into for every unit I have 2 blocks. So 2 blocks and then -1, 2 blocks and -2. For my y-axis, it's every block is a unit. This is a -1 and that is a +1. I tried to write it properly and made it look like 2's, so my apology. So a -1, a 1, a 2, and a 2. Alright, so there's our first point. It's somewhere all the way down here. Our next point is a -1, 6. So -1, 6. Next point, 0, -4. 0, -4. Next point, 3/4, a -11 halves. Okay, so there's my 3/4. Come down here, there's 10, there's 11, so somewhere there, we'll say. And then 1/2, so there's 1, there's a half, and then a -9.6, so somewhere there. And then 3 and 50, and 3 and 50, 50 is, and it's on somewhere up here. Okay, so somewhere up here is 50. And then my zeros that I actually had, so I had a -2, a -1/3, so that's a half, so we'll say it's there, and then value of 2, so right there. And then what I need to do is just connect the dots. So it's gonna come somewhere up here like this, it'll peak somewhere, and then it's going to hit that point, and then it's dropping down here to hit that x-axis, going here. And as you can tell, this is just a rough sketch. I'm just, I guess you could say I'm speculating. It probably goes a little lower in order to make the turn up, and then continues on up here to 50. Somewhere in this one is a negative 50. Let me erase that. And this is where it would be nice to be able to calculate the actual maximum and minimums of the graph. Again, you need calculus for that, and take the derivatives, use the first derivative test to be able to turn maximum and minimums. Okay, so what I want to be able to show you is this is what this is for, being able to do it by hand. For your homework problems, you'll select between 4 different graphs which one represents the data. They're not drawn to where they're so close you can't tell. It's pretty obvious. Okay, so let's look at the TI 83 or 84 and see if I can actually get this to come on. Yes, it did. Here we go. So here's the 83 or the 84, and I've put in the function, and then what I can do is I can go to table set, and I pick my interval. If these were all just whole numbers, I could select 1, but since I have some that, over here for my x values is what I'm selecting, since I have some that are broken down, say by fourths, because I have 1/2 and 3/4, I put in 0.25, and I'll just start at 0, and then I go over to the table. This gives me all of my values. I can scroll through here instead of having to work each one of these out by hand. Just go through there and look. So a negative 3 is a negative 40. And this will give me all my values. That's where I messed up. I was trying to look over at it and hurry up and write those down for you on the last video. Okay, so the joys of trying to figure out lighting in order to make these movies. Here's my rough sketch. I can use Desmos, I can use my TI 83 or 84 to get the ideal sketch, and using technology is a lot better because I would have to pick a lot of different points and keep refining them, and eventually I could find the actual maximum and minimum. But that takes a lot of time and a very large area to graph on. So use technology to be able to do it precisely. In the subsequent videos, what I'm going to do, and here we go. How about I show you this though? You see our graph, how it looks. I wish that I could figure out the lighting. Maybe this will work and you can see both of them next to each other. There's my graph. And I'd say that we did a decent job. Not a good job, decent. Alright. What I'll do is I will work one more of these problems on here and take less time explaining each step. I'll just work through and show each step, boom, 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 and have it done, and be able to show you how you can, again, come up with a rough sketch and have an understanding of this is what polynomial is represented by the given function. Guys, please watch your instructor's videos. Critically think about what you're doing and how you're structuring it. Watch you out hurrying up. You'll make mistakes like me. And good luck with your homework.